completed problems A, B, and C. So let's take a look at problem D. In problem D, we have the square root of negative 40 over the square root of negative 10. So the first thing that we would like to kind of tackle is those negatives inside of the square root. Both negatives inside of the square root will come out as i's before we do anything else. That will leave us with the square root of 40 inside of the root up top and a square root of 10 inside the root on the bottom. So at this point, all we have done is taken out the i's. Now, you may be wondering, well, I have an I on the numerator and an I on the denominator. Had these been x's, we would have, without thinking, canceled out the x's. And we're going to do the same thing here. We've got an I on top and an I on the bottom. We will cancel those out. Now, we've got the square root of 40 over the square root of 10. Well, we have two separate square roots. Remember, we can put square roots and pull them apart, or we can put them together. Well, what we'd like to do this time is actually put them together. So instead of doing two individual roots, let's put them as one big root. So this will turn into, let's see, one big square root over, it's still going to remain the same, of 40 over 10. But now if they're both inside of one big root, then I can just go ahead and do the math first. What is 40 divided by 10? Well, 40 divided by 10 is just 4. Notice the square root symbol, though, is still there because we have not taken the square root yet. So my last step is just to remember I have to take the square root of what I have, which is 4. Well, the square root of 4 is just 2. So my final answer for this whole problem is just the number 2. Let's take a look at E. In E, we're going to do the same type of thing. We're going to look at the fact that the top has a negative inside of the square root. So we will pull that out. It will come out as an I, leaving us with still the square root of 160. And the square root of 10. Notice there was no I this time to pull out of the square root in the denominator. What does that mean this time? It means that there is no way to cancel out the I that's on top this time. That's okay. It just means my final answer will have an I in it. What we can do, however, is we can simplify the square root of 160 over the square root of 10 by turning it into one big square root of 160 over 10. Then we can get away with just going ahead and doing the division first. So that will leave me with I. We still have the square root because we haven't taken the square root yet. But 160 divided by 10 is just 16. Now we can take our square root. Now, taking the square root of our 16 will come out as a 4. So that will come out as a 4. But remember, we already had the I there, so it'll actually become a 4i. And that's our final answer. Our final answer for this whole thing on E is 4i. The last thing that we're going to look at with complex numbers, or these imaginary numbers, is adding and subtracting. And just like anything in the past, if we had, let's say, a 3x plus 2, let's say, and we were adding it to a 6x plus 8, how did we do something like this in the past? Well, we'd add the 3x and the 6x, which would give us a 9x. And we would add the 2 and the 8, which would give us a positive 10. And we would be done. You would not be able to add the 9x and the 10. And the reason why we were able to add the 3x and the 6x, and then the 2 and the 8 is because they were like terms. So the key idea behind all of adding and subtracting. When we added and subtracted fractions, we had to have a common denominator to make them kind of similar or kind of like terms. So the idea is, again, when you're adding and subtracting, they need to be like terms. Same thing here. When we have imaginary numbers, regular numbers can only get added with regular numbers, and imaginary can only get added or subtracted to imaginary. Now notice, how do we know we're adding or subtracting? Look at the little sign that's in between your two complex numbers. In this first one, it's a plus, which means we're going to just add normally. So you combine your like terms. Let's see what happens. Well, you'd first start out by adding your 8 to your negative 7, which is a positive 1. And then you take a look at your I terms, which is a positive 3i and a negative 2i, which gets you a positive 1i, which is just an I. And that's it. You're just adding and subtracting, nothing fancy. You're just combining like terms. Let's look at another one. This one is a little bit different because we have a minus sign. We're subtracting. So what we're going to do when we have a minus sign, you may have seen this a long time ago when we did x's, is you actually have to distribute the minus sign to everything. So the minus sign will turn the negative 2 into a plus 2. And then the negative sign will turn the negative 8 into a positive 8i. Now what I would do is once you distribute that negative sign that's in the middle, it's gone. It's dead in the water. So that's gone. And our first piece, the negative 7 plus 9i, is going to remain the same. That doesn't get touched because it didn't have anything out in front of it that would change it. Then you can just add and subtract your like terms normally. Well, your first two like terms are your negative 7 and your positive 2, which will just get you a negative 5. Your second group of like terms is your 9i and your 8i, which will get you a positive 17i, and that's it. Though the negative 5 and the positive 17i are not like terms, so you can't go any further and you are done.